Have you ever looked at a massive factory or a chemical plant and just wondered, how on earth did they design that? Well, today we're going to pull back the curtain on a modern university engineering course to see exactly how the next generation is learning to build our future. Let's dive in. So, this is really the big question, isn't it? What does it take to design these factories of the future? We're talking about something far beyond just pipes and valves. It's all about creating systems that are smarter, cleaner, and way more efficient than anything we've had before. So, where do you even start with a challenge that huge? Well, it all starts with understanding the incredibly high stakes of modern chemical engineering. Yeah, it is so much more than just mixing stuff in a lab. Today, it's all about these three pillars: safety, sustainability, and economic viability. Think about it. A design that isn't safe is a non-starter. A design that destroys the environment isn't going to fly. And if it's not profitable, well, it's never going to get built. The real genius is finding that perfect balance between all three. So how in the world do you juggle all of that at once? You can't just guess. You need an incredibly powerful tool. And for modern engineers, that tool is something called process simulation. The best way to think about it is like a super advanced video game or a flight simulator, but for a factory. You get to build the entire thing on a computer, you can run it, you can push it to its limits, you can see what breaks, and you can tweak every little detail, all before spending a dime on actual construction. It's a total game changer. And here's the real magic of it, pulled right from the course description. It's the fast calculation ability. The computer handles the millions of mind-numbing calculations, which frees up the engineers to do what humans do best. Think about the big picture. They can focus on those crucial questions of safety and sustainability instead of being buried in spreadsheets. And this isn't just theory. To make it real, students get their hands dirty with the actual software the pros use. In this case, it's a program called Aspen HYSYS, which is an industry standard all over the world. So how do you go from opening a program for the first time to designing a whole virtual factory in just one semester? Well, it's a very carefully planned journey. The whole semester is basically like a training montage in a movie. You start with the basics, just getting comfortable with the tools. Then you start combining smaller systems, learning how a reactor connects to a separator. Week 8 hits, you've got your midterm test to make sure you're on track. And then the entire second half is all about the final projects, applying everything you've learned to a big real-world design. It's all about building up skills and confidence 1 week at a time. And believe me, this is no walk in the park. We're talking over 113 hours dedicated to just this one course. And look at the breakdown. Sure, a lot of it is guided learning in the classroom, but a huge chunk is independent study. That's where students really have to push themselves and solve problems on their own. This thing requires a serious commitment. So what's the grand finale? How does all this training come together? It all leads up to the final test, solving actual real-world problems where everything they've learned gets put on the line. And check this out. This is a quote straight from the syllabus. They're given a real industrial process design project. This isn't some made-up problem from a textbook. The whole point is to close that gap between what you learn in a classroom and what you do on the job. But here's the kicker. They don't do it alone. The entire thing is built around what the course calls cooperative learning. That means it's all done in teams through these intense design projects, which is exactly how big engineering projects get done in the real world. So, how big are these teams? Are we talking about a whole class working together? Nope. We're talking about just 5 students. 5 people huddled together trying to solve a complex industrial problem. It's meant to feel just like a professional project team. And all that work leads to 2 massive final projects. The first one is all about process design. That's the core of it, just figuring out how to make the product correctly. But the second one, that's next level. It's about process integration. That's where you learn to make the whole system smart and efficient, optimizing how all the pieces work together to save energy and money. So after all this, after 14 weeks of grinding it out, what do these students actually walk away with? Let me tell you, it's a whole lot more than just knowing how to use a piece of software. You've really got 2 sides of the coin here. On one side, you've got the hard technical skills, analyzing, designing, simulating. But on the other, you've got these crucial career skills that are forged in the fire of those team projects. Teamwork, communication, and learning how to learn. You literally cannot pass the course without getting good at both. And this happens by design. The course uses this really modern approach to teaching. It's a blend of active, hands-on stuff in class, those cooperative team projects we talked about, and it's all supported by online tools. It's this whole strategy designed to create well-rounded problem solvers, not just button pushers. So at the end of the day, this isn't just a course about software. It's a training ground for a whole new way of thinking. It gives engineers the digital tools and the collaborative skills they need to go out and tackle those grand challenges we started with. Which really leaves us with one final exciting question. With an education this practical and with tools this powerful, what will this next generation go on to design?